fun with the first and second derivatives. So, first problem is to find the values a, b, c, and d. And what do we know about it? We know that f of x is ax cubed plus bx squared plus cx plus d. Plus d. And we also know that f of x has a min value at 0, 0, and our max value, or a max point, not just the value, a max at, let's say, 2, 2. We have a max at the point 2, 2. Now, there are 4 unknowns, so we need 4 pieces of information. Well, we know that when it comes to f of x, 0, 0 is a point. How can the min of f of x be at 0, 0? Is 0, 0 is not a point on the graph. And we know we're second point on the graph. We also know that the first derivative is 0 at 0. It's the only way you can be a min. And we also know that the first derivative equals 0 when x is 2. After all, how can you have a min? Those are our 4 pieces of information. So first, let us find f prime of x. Just bring down the 3, multiply it by the a, make the new power 1 less. Multiply the 2 by the number in front, make the derivative, make the power 1 less. The derivative of a constant times x is the constant, and the derivative of a constant is 0. Okay, so we know that f of 0, I'm concentrating on this point, is, well, a times 0 cubed is 0, b times 0 squared is 0, c times 0 is 0. You add those 3 zeros, you get 0, and then when you add d, you get d on one hand. On the other hand, we're supposed to get back 0. So I know where d is. That's really great. Now, let us find out what f of 2 is. 2 cubed is 8. So I get 8 times a. 2 squared is 4, so I get 4b. c times 2, or 2 times c is 2c, and we already know d is 0. And this sum should also equal 2. So that's the second equation we have. So we have 2 equations involving just f of x. Now we have 2 more equations. We know that on one hand, f prime of 0 is going to be 0. So we have 3 times a times 0 squared. Oh, I thought for a moment this was all f prime of x, but we do have the rest. So 3 times a times 0 squared is 0. 2 times b times 0 is 0. 0 plus 0 is 0. And then we add on c, and we're supposed to get 0, because x equals 0 was a critical point. So the derivative should be 0. Okay, so now we have c and d outright. In fact, in this equation up here, I'll even cross out 2c. Because 2 times 0 is 0, and adding 0 doesn't do anything. Now, the derivative at 2, well, 2 squared is 4 times this 3 in front is 12 times the a, plus x is 2 times 2 is 4 times the b is 4b, and adding c, we already know c is 0. But this is 0. Okay? So over here, I have the value of c and d, and these two equations over here only have a and b. Okay, the first equation, let's call that 1 and 2. The first equation I'm going to divide by 2 to get the numbers smaller. So I have 4a plus 2b is 1. This equation, I'll divide by 4. So I have 3a plus b equals 0 divided by 4, which is 0. Okay, so maybe I should have just divided their second equation by 2, but now I'm going to double it. So I have 6a plus 2b equals 0. And the reason I doubled it is because this equation on top already has 2b. So now if I subtract, let me do the bottom minus the top. 6a minus 4a is 2a. 2b minus 2b is 0. And 0 minus 1 is minus 1. Divide by 2, you get a is negative a half. Okay. Now, I want to find b. I'm going to jump on this equation because it just has b. The equation above has 2b. That is, I'll find out what 2b is, but then I have to divide by 2. Okay, 3 times this number is negative 3/2. What do you add to get to 0? The answer is 3/2. So now I have A, B, C, and D. And maybe for completeness, we should write it down over here. A is equal to negative a half. B is equal to 3/2. C was 0. That came from here. And then while I'm here, D is 0. There are my results. If they ask you to find f of x, which they did not, you can say f of x is neg a x cubed plus b x squared plus 0x plus d, 0d, which you don't even have to write that. This is, minus some silly arithmetic error, that is f of x. I mean, we can check it. F for 0, I hope that's clear that that's 0. Well, what is f of 2? Well, it's a negative a half times 2 times 2 times 2. I did that so I can see that 2 cancels out. Plus 3/2 times 2 times 2. So what I get is negative 1 times 4, which is negative 4, plus 6, which is 2. And they told me that when x is 2, y should be 2. Okay, that's good. Now, what about the derivative? The derivative of f of x, well, bring down the 3, get negative 3/2 x squared plus 6/2 x. Okay, and we set this equal to 0. So I have a 2 on the bottom I can factor out. I can factor out a negative 3 and an x. So the only thing I didn't pull out from here was that second x. Minus, I pulled out the x and the 2, and I pulled out a negative 3 from the top, which gives us a negative 2. And this equals 0 when x is 0 and when this is 0. Okay, but I'm not going to verify that they are max and mins, but that's exactly where I think this was a min and that was a max. Yeah. Okay, so here, it checked out. So letter C, everything below this green line is a check. F for 0 equals 0, F for 2 equals 2, and the first derivative is 0 at 0 and 2. If you wanted to check further, well, think about it. At 0, if x changes from a little bit less than 0 to a little bit more than 0, the sign of this will change because the power is odd. It's a 1. If you're a little bit more or less than 2, then this factor is going to change signs around 2. If x is 1.999, when you take away 2, it'll be negative. And when x is a little bit more than 2, and you take away 2, it'll now be positive. As long as the sign of the first derivative changes at 2, you're going to either have a max or a min. And if the first derivative changes when x changes signs around x equals 0, you're going to have a max or a min. So yeah, this looks fine. I'm happy with it. But of course, you don't have to check it. Now, suppose you come to know the following. Suppose you know that f for 2 equals f for 4 equals 0. And you're told that f prime of x is less than 0 if x is less than 3. F prime of x is greater than 0 if x is bigger than 3, and that the second derivative is negative if x is not 3. And the goal is here is to actually graph f of x. Okay. So the first piece of information tells me when x is 2 and 4, the y value is 0. Okay, so I have those 2 points. And 3 definitely comes up. You know what? Let's spread this out more. So here's 1 and 2 and 3 and 4. 1, 2, 3, and 4. So f for 2 and f for 4 are both 0. 4 and 5. Okay. Now, if x is less than 3 and x is more than 3, so I don't know, maybe I'll put a little line here. If x is less than 3, the first derivative is negative. That means that it's going to come down like this. But remember, it has to cross 2. It comes down like that. All right. And if x is more than 3, the first derivative is positive. That is, it has a positive slope. So I go like that. Right? Then the second derivative says that it's, except when x is 3, it is concave down. Remember, concave down is some portion of that. Well, it can go like that. It must go like that or like that. This is concave down. Slopes are always positive. and this is concave down, the slopes are always positive. And there is your graph. You don't need this. It helped us. How did it help us? Well, this piece is also concave down. But the problem is that the slopes are positive. When x is less than 3, the first derivative tells you the slopes, and they're telling us, hey, they're always negative. So that's why this was not correct. And here is your graph. And they never told us anything about 3. I mean, you could graph it with an open circle, or if you like, you can have the circle filled in. They just said graph any graph that has these properties. And, I mean, for example, if I remove that point, it's fine. It lived up to everything. Well, okay, no it didn't, because it says if x is less than 3, the derivative is negative. The derivative is not defined at that point, so it's not negative. So it does have to be filled in. But it doesn't say anything about at 3 except that the second derivative is not negative. And whether you fill in this point or not, the second derivative isn't negative. Okay. Having fun already? Let us consider the next problem. I wrote down a few of them. Suppose you come to know that f for 0 is equal to f for 2, which equals 0. And the first derivative, that is the slopes, are negative if x is less than 3 and, less than 1. First derivative is less than 1. It turns out that f prime of 1 is 1. F prime of x is greater than 0 if x is bigger than 1. And f double prime of x is always positive. That means it is always concave up. Alright, so let's graph this. We know that f for 0 is 0 and f for 2 is 0. Okay. And so I took care of this. And they said if x is less than 1, if x is more than 1, let's put a little line here. Again, in the end, you may want to erase that line. If x is less than 1, the slopes are negative. That is, I'm coming like this. Okay. And the derivative at 1 is 1. So here's 1. The slope is 1. Okay, if you say so. And if x is more than 1, the derivatives are suddenly positive. The derivatives are positive. Okay, so I took care of this piece, the one to the left of that, this piece, I just took care of this piece. Now it's always concave up. Okay, so I come down, concave up. I cross at the origin and I okay, so we have to make sure that we're 1, the slope is 1, right at 1. Okay? We have to make sure of that. And 2 other things. I have to cross here and here. So it's coming down, it concave up. So go something like that. I guess that's the point where x is 1. This is where x is 1 because the slope is about 1. So my dashed line is off a little bit. It's going to be a pain to actually graph these. You know, who knows, maybe you should put the numbers in afterwards. But right above that point, I put my 1. Okay, the slope here is 1. It's always concave up, and it has a 0 here and here. And to the left of 1, the slopes are all decreasing. To the right of 1, the slopes are all increasing. Okay, so I satisfied all 5 pieces. And that one is done. Suppose you have this. Suppose once again f for 0 is equal to f for 2, which is 0. There's one piece. And this time they tell us that the derivatives are positive if x is bigger than 1. They tell us that the derivative at 1 is identically 0. They tell us that the slopes are all negative if x is less than 1. And they tell us this time the derivative, the second derivative is always negative. That means it's some portion of that. Okay? One, 2. So things are going on at 1. F for 0 is 0 and f for 2 is 0. I guarantee you I'll cross those 2 points. If x is bigger than 1, my slopes are positive. Now, remember, I have to cross 2, so I must be down here getting positive. I can be up here getting positive because I'm going to have to go negative to cross at 2. And the slopes are not negative bigger than 1. Okay, so far I'm living up to that. The derivative at 1 should be horizontal. Okay, and f prime is negative if x is less than 1. Okay? And there's no reason why we can't match at that yellow point. And the derivative, the second derivative is always concave down. Looks to me that we have a serious problem. Because if the slope is 0 here, now this is going to have to be positive. It's concave up. So the graph goes like that and it crosses at 1. So what's in pink, that's the graph. f for 0 and f for 2 are 0. That's true. I lived up to those two statements. If x is more than 1, my graph is increasing, okay? The derivative at 1, yep, it's 0. And if x is less than 1, the function should be decreasing, and it is. And the second derivative is always positive. It is concave up. There it is. This is bigger than 0, which means concave upward. This time, I'm going to give you a function, give you a graph. Let me give it to you. You have this graph, call it f of x, and you are to graph f prime of x. Maybe I'll do it in another color. Well, first, let me extend this so I can label the axes. And I know that right here, the slope is 0. So I'm graphing their slope formula, f prime. And right here, the slope is 0. I have to cross those 2 points. Now, let us see what's happening. Slope is very positive, little less positive, small, very small, and 0. So basically, I'm very positive and I'm coming down to 0. Now, after 0, my slopes are negative, little bit more negative, very negative, very, very negative, and right here, it starts getting less and less negative, and it comes to 0. So, let us maybe have another point right here. Say that's the point of inflection. So, my slopes are a little negative, more negative, very, very negative, very, very negative. Okay? So, it's going down, down, and down. But like always, let's dot it. Going down, down, and down, up to this point. After that point, the slopes are, like I said, negative, little bit less negative, small negative, and then 0. It's going up to 0. And then after this is little positive, more positive, very positive. It's just going up, up, and away. And just want to, oh yeah, so it had to be 0 here. So, and there's the point of inflection. That's where the second derivative changes. It has its max or min. Okay, so the function goes like this. Sorry, the first derivative. That's f prime of x. Now, drew a lot on this graph, so let's come over here. This here is f prime of x. Okay, now I want to draw the derivative of this function. This is just a name. The derivative of this is f double prime, but it's still just the derivative of this graph. This has a slope of 0 here. So the derivative of this function, which happens to be the second derivative, but the derivative of the given function, its slope is 0 here, so the derivative of that function will be 0 over there. Now, it has a very negative slope, less negative, little negative, very little negative, and then 0. It's going from very negative to 0. Okay? And then after this point, it's a little positive, more positive, very positive, very, very positive, really positive. It's just going up, up, and away. In fact, it's going to be a line. Now, how did I know this? This green function is a cubic. And any time you have a cubic, which is in this form, and you take the derivative, you get 3ax squared plus 2bx plus c. You get a quadratic. Well, there's my quadratic. Here is my quadratic. And then if you take the derivative of this quadratic, look at this. You get a line. mx plus b. You get a line. That's why I drew a line, okay? But there it is. Given f of x, I drew f prime and I drew f double prime. Let us finish this section by doing the same thing with this function. That is the function y equals g of x. Y is equal to g of x. And we want to draw the first derivative. Okay, find the zeros of it. It's 0 here and here where the slope says 0. And a little bit below that point, below that line. Okay, so we are graphing the slope formula. Well, the slope is 0 here, and here, and here. Okay. Now, since this has 4 zeros, 1, 2, 3, 4, well, we're gonna assume that it's a quadratic graph. Cx squared plus dx plus e. So the first derivative is gonna be a cubic. 2cx plus d. And the second derivative, oops, that's 12. That's going to be a quadratic. Okay, this just kind of tells us what type of graph we're going to have. Okay, so we found a few points on the line. We found this point, and that point. Now, let us see what's going on with the slopes. Very positive, less positive, smaller, smaller, very small, 0. Okay, so it's very positive and it's coming down to 0. Okay, now after 0, it's a little negative, more negative, very negative, and maybe like right there, that's the most negative. Now it's still very negative, but a little bit less, very smallly negative, and then 0. So it's gonna keep coming down, but like I said, right about here, it starts to get less and less negative. Okay, but let's get rid of this because it really isn't part of the graph. Now, what happens after that point? That point being this point here. Well, it's positive, little positive, very positive, insanely positive, and maybe right there it changes. A little bit less positive, still big positive, but less, just a little positive, very little, and then 0. Okay, so what's happening is all the way up to here, the slopes are positive. From this point here, all the way up to here, the slopes are positive. But they're getting less and less positive, and then they're going to eventually be 0. So right above here, slopes are positive, 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 positive. But now they're still positive, but they're decreasing. It's going down to there. Okay? Now, I'm just going to look at the slope some more. Little negative, more negative, very negative, even more negative, just down, down, and down. Okay, so it's just going down, down, and away. Okay, let's try our best to get rid of this stuff over here. And now, this is a little important. We know it's a cubic. So I would draw the cubic like that. I pass the key points. Okay, I would draw the cubic just like that. Okay. The pink graph is G prime of x. Now, maybe underneath, I'll draw, and to the right, here, to the right, I will graph the second derivative. Okay, so we have our function, the pink one, going like that. And again, I don't care what we call it. Don't get caught up by the name. I want to draw the second derivative, fair enough. But that's just the derivative of this yellow graph. So let's draw it. Well, the slopes are 0 here and here, the slopes of the tangent lines. So the slope function of this graph, the slope function of G prime, just happens to have the name G double prime. Don't let names get to you. Okay, so negative slope, less negative, little negative, very little negative, hardly negative, and then 0. So here is very negative, and here is a little negative, and here is 0. It's going like this. Now, after this point, the slope is positive, more positive, very positive. There's a point of inflection. The most positive it gets, and then they're positive, but they're getting closer and closer to 0. So we're going to increase up to, say, here. Well, I drew that line a little bit too much, so I erase it. I'll even erase my scrap work. Now, after this point, up to this point, the slopes are still positive, but they're getting less and less positive, and eventually they're 0. Let me even dash this line. Okay, what happens after this point? Negative slope, more negative, extremely negative, just down, down, and away. But the second derivative is a quadratic. So that's the max, and it goes like this. It's just a U shape. And nobody's going to take out a measuring stick to make sure that you graph this neatly. But basically, here it is, please. This here is your first derivative, and this is y prime, and y double prime is going to look like this. It's going to have a 0 here and here, and it's going to have a point here. So it's just going to look like this. This finishes the video, Fun with First and Second Derivatives.